Hello class, welcome to our lesson today dealing with section 6.4. This deals with different types of estimators of sampling distributions. To be honest, we're not going to do a whole lot with this section, so it's more just information, just to make sure we understand some of the things that we're doing in this class. So there won't be a ton of questions about this on your homework. The one thing that you want to look at for this section is what we're looking at is all the different samples of the same size that are taken from a population. So that's what it means by a distribution of the samples. So the idea is you take all the values that could be possible and see what happens with those size of sample space, and to see what happens with those situations. The number one thing that you want to take away from today's information is what's an unbiased estimator and what's a biased estimator. Okay, unbiased estimators are what you want to look at typically because they target the population parameters and what it should happen with the population. So examples of that would be the sample mean. Okay, we call that X bar. Okay, so for the sample mean is X bar, excuse me. Okay, so you got the sample mean right here, denoted X bar. Sample variance, which is the standard deviation squared, which is S squared. And the reason that we learn about variance earlier on in the semester is because then it can be used as an unbiased estimator as you move forward in statistics. And then the last group is the sample proportion, which is p hat. P hat is the proportion of whatever the sample is. So if it's like number of tosses that are tails out of the total, that would be an example of p hat. Biased estimators don't target the population parameter very well, so they can't be used to explain some of those things by themselves. So for example, the median doesn't necessarily target what the population says. The range of data doesn't target what the population would say. And standard deviation also does not. So we think that standard deviation is this kind of gold standard for measures of variation, but it doesn't really approach anything in terms of the population in small sample sizes. Now, you'll make a note here that says once the sample size is much larger, then it does become an unbiased estimator, and that makes it a better and more accurate description of what the population is dealing with. This question here, basically what's happening is you're basically saying select 3 households that serve as a pilot for a study. The number of people in the households are 2, 3, and 10. If you consider the values of 2, 3, and 10, okay, you're assuming the population is size 2, and you randomly select with replacement from the population. So here's basically what you're saying. You have 3 cards that you can pick from. There's a 2, a 3, and a 10. Well, since it's with replacement, what could happen is you pick a household that's size 2 and then another household size 2, or size 2 and size 3, or size 2 and size 10. And then you could do the same thing with all the others. You could do 3 and then 3, 10 and 3, 10 and 10. And basically what it's saying is, are all of them equally likely to be chosen? And in this case, the answer is yes, because it's with replacement and everything is going to be of the same likelihood of being chosen. So again, there's not a whole lot. I've gone back and forth with what to assign kind of from this section. I'm not going to plan on giving you too many questions with this, but the idea is if we found the average of those, that would give us a good estimate because it's an unbiased estimator of what would happen in the actual circumstances. Okay, so the different types of samples for that would have been just listing them all out. The sampling distribution, you can look at the table, and so you can figure out kind of the average of each of those. And so does it target the population mean? The answer is yes, because everything is accounted for, everything is equally likely, and the means will match themselves up. But it's kind of a different way of thinking, and honestly, we're going to focus more on the next section in the next day. So let's just make sure that we understand biased versus unbiased in this section. Honestly, the biggest thing is the chapter 6 review from section 2 and 3, the questions that I've been handing out the past couple days. Those questions are going to be more important as we move into our next section, which is known as the central limit theorem. That section is in section 6.5. So honestly, as long as you have biased, unbiased figured out, just separate them and just have a list of them. And then look at section 2 and 3 of chapter 6. Make sure you know how to find z-scores. Make sure you know how to work backwards. Make sure you know how to interpret your graph, etc., and your tables. Those things will be much more important as we move forward into our next lesson. Your homework's going to cover a few things from this section, but the majority of it's going to be section 5 and then some review questions from these 2 sections. So you just want to make sure that you're working a little bit ahead on that. I tried to order it to do the review questions first, so that should get us kind of back going in that direction, and then we can look at that as we move forward. Have a good day, everyone.